Hey guys, Mr. Game. Today we're going to look at drawing tree diagrams and probability of compound events. Alright, so here's our first example. I have a jar with 7 blue marbles and 3 red marbles. Draw a tree diagram to show picking 2 marbles with replacement. Alright, so a couple important things. I have 7 blue marbles. I have 3 red marbles. That's important. That also means that I have 10 marbles altogether. Alright, I'm picking 2 marbles at a time, and I'm going to have replacement. Alright, so there's going to be a first pick, a second pick, I'm done, 2 marbles, and I am replacing the marble after the first pick. Alright, so I'm going to label first pick, and when I do my first pick, well, there's only 2 things that could happen. I could either pick a blue marble or a red marble, so I'm going to use B for blue or for red. Alright, I have 7 blue marbles and 10 altogether, so the probability that I choose a blue marble is 7/10, and I'm going to put that right on the branch. Red is 3 out of 10, so I'm going to put that on the red branch. Alright, that's our first pick. Alright, now I'm going to label second pick. So if I pick a blue first, well, my second pick, if I replace that blue marble, well, I can still pick a blue marble or a red marble. If I choose a red marble first and I replace it, on my second pick, I can still choose a blue marble or a red marble. Alright, since I replaced the marble after the first pick, I still have 7 out of 10 marbles that are blue, 3 out of 10 that are red, 7 out of 10 that are blue, 3 out of 10 that are red. Okay, so the probabilities are not changing. Alright, then I have a column that I call outcomes. These are just all the possibilities. Okay, and I'm just going to follow the branches. So, follow blue, blue. Follow blue, red. Could have done red and then blue. Or red, red. Right, there's the only 4 possible ways that I could choose 2 marbles with replacement. I could get a blue and a blue and then a red and a blue, or I could get 2 reds. Alright, my last column is my probability. I ran out of room, so I'll abbreviate that. Alright, to get probability, I just multiply the probabilities of each branch. So blue, blue. I've got this 7/10 and this 7/10. Multiply them together, I get 49 100ths. Okay, that's blue, blue. Blue, red. That's the 7/10 blue and the 3/10 for red. Multiply those together, I get 21 100ths. Probability of red, blue. So that would be that red and that blue. 3/10 times 7/10, 21 100ths. And then red, red, that 3/10 and that 3/10. Multiply them together, I get 9 100ths. Right, if I added those 4 probabilities up, 49 100ths, 21 100ths, 21 100ths, and 9 100ths, I would get 100 100ths, which equals 1. Right, now you're going to get some questions like, now what's the probability that you choose blue first and blue second? Well, I already have it over here. Blue, blue is this right here, 49 over 100. So my probability is 49 over 100. Alright, then you might get some questions like, what's the probability you get at least 1 blue? Well, at least 1 blue would be blue, blue, that's at least 1. Blue, red, that's at least 1. And red, blue, that's at least 1. They all have at least 1 blue. So I would add these 3 probabilities up. 49 100ths, 21 100ths, 21 100ths. And I would get 91 100ths. Alright, and they're the kind of questions that you're going to see for probability. Alright, so that's tree diagram with replacement. Alright, now we have an example. Looks very similar. Jar, 3 blue marbles, 7 blue marbles, 3 red marbles. We're going to draw a tree diagram again showing 2 marbles, picking 2 marbles but this time it says without replacement. So that's going to change things a little bit. So let's label first pick. Let's get our branches. We know that there's only two things that could happen. I could choose a blue marble, or I could use a red marble. Abbreviating again. Blue, once again, we have 7 blue, and there's 10 marbles altogether, so 7 out of 10 for blue. 3 red out of 10. 3 out of 10 for red. Alright, we're going to take a second pick. Alright, but this time I'm not replacing the marble. So let's say I choose this blue marble first. On my second pick, if I don't put that blue marble back, what do I have in the bag or in the jar? Well, I still have some blue marbles and I still have some red marbles. Okay, but I don't have 7 out of 10 blue marbles and 3 out of 10 red marbles. Because if you think about it, if you don't put that blue marble back, now you only have 6 blue marbles and there's only 9 marbles altogether. So that's going to be 6/9 or 2/3 if I reduce it. And then red, there's still 3 red, but there's only 9 altogether. So that's 3/9 or 1/3. Alright, let's come down here. If I start with a red marble and I don't replace it, well, I still have some blue and I still have some red. But it's different. It's not going to be 7/10 and 3/10. If I start with a red marble and I don't put it back, I still have 7 blue marbles, but I only have 9 marbles altogether because I didn't put one back. If I start off with a red marble and I don't put it back, now I only have 2 red marbles and there's 9 marbles altogether, so 2 out of 9. So you can see this example compared to the last one. On that second pick, the probabilities change because this probability is dependent on that first pick that I did not replace. Remember, without replacement is dependent, with replacement independent. Alright, so then we have our outcomes column. Alright, so we're still going to follow the branches. I can get a blue and then a blue. I can get a blue and then a red. I can get a red, then a blue. Or I can get 2 reds. Alright, so outcomes are the same. Probability. Remember, we're going to multiply the branches. So blue, blue, well, that's the 7/10 and the 2/3. Multiply those together. Well, let's do 14/30, and then we want to simplify that. And that's going to be what? 7/15. Now we'll do blue, red. So that's going to be the 7/10 and the 1/3. Multiply that together. I get 7/30. That is Low's terms. Red, blue will be that 3/10 and that 7/9. And that's going to be what? 21/90. But I can simplify that because they're divisible by 3. 7/30. And then we have red, red, which will be 3/10 and 2/9. That'll be 6/90. Which I'll simplify because 3 goes into both of those. 2/30. One more time. Well, 6 went into both of them. 1/15. Alright, once again, if I add up this 7/15, 7/30, 7/30, and 1/15, it would add up to 1. Alright, now we're going to get questions like, what's the probability that I get, let's say, red first, then blue second? Well, that's right here, and that's right there. Alright, how about this one? What's the probability I get exactly 1 red? Exactly 1 red. Alright, the last time we were looking for at least, but now we're looking for exactly 1 red. Exactly 1 red is here and here. Not there. That's 2 reds. That's not exactly 1. So here and here, that means 7/30 and 7/30. I add those 2 up, and that's going to be 14/30, which I'm going to simplify to 7/15. Right, so those are the kinds of questions that go along. And this is compound probability because we're looking at the probability of 2 things happening, the first pick along with the second pick. Alright, so that's our tree diagram. and then some probability questions go along with it. Tree diagrams can be a little tricky at first, but it's a great way of organizing and seeing real clearly what all the outcomes are, and a way to get that probability on there so you can easily answer any kind of probability question. All right, good luck, guys.